Well, here we are in Chapter 2, Math 20-1 on trigonometry. Today we're doing topic 2.1, and the first thing we're going to look at is angles in standard position. And this is for angles between 0 and 360 degrees. An angle in standard position must have these characteristics. First of all, the initial arm must be on the positive x-axis. The vertex is going to be at the origin, and the angle is going to be measured counterclockwise from the x-axis to the terminal arm. Let's look at 4 different examples. In the first one, that is going to be our initial arm. The terminal arm is going to be in the first quadrant, and quite simply the angle is going to be that size between the x-axis and the terminal arm. Now in the second picture we're going to move the terminal arm to be in the second quadrant, and the angle is going to be the obtuse angle between there. In the third picture, our terminal arm is going to be now in the third quadrant, and our angle measure is going to be greater than 180 but less than 270. And lastly, our angle in standard position is going to measure between 270 and 360. That is going to be the measure of our angle in standard position. Now, for each angle in standard position, there's also going to be a corresponding acute angle, and that's going to be called the reference angle. It's going to be measured in degrees from the angle, from the terminal arm, back to the nearest x-axis. And it's always going to be measured as a positive value. Here we have, whatever this angle is, let's say that this is a 70-degree angle, that is also going to be a measure of our reference angle. It's going to be the same thing because it's going to measure back to the x-axis. In the second picture, let's say that this is a 120-degree angle. The reference angle in this case is going to take us from the terminal arm back to the x-axis, and that's only going to be 60 degrees. That's going to be our reference angle, from the terminal arm back to the x-axis. In the third picture, we have a 210-degree angle. That's our angle in standard position. Our reference angle now is going to be measured back to the 180, so that'll be a 30-degree angle. It's going to take us back to the x-axis. And in our last picture, we have a standard angle in standard position of 300 degrees. From the terminal arm back to the x-axis is going to measure 60 degrees. So that's our reference angle, 60 degrees. There's going to be some special right triangles that we're going to investigate. These are for angles of 30, 45, and 60 degrees. You will need to determine the exact value of the trig ratios for these triangles. Now, can you recall SOHCAHTOA? I hope so. That means that the sine of an angle is the opposite over hypotenuse. Cosine of an angle is the adjacent side compared to the length of the hypotenuse. And the tangent of an angle is the length of the opposite side of the triangle compared to the adjacent side. Well, let's start with a 45-degree, 45-degree, 90-degree triangle. That would be an isosceles triangle. And the two sides opposite the 45-degree angles are going to be the same measure. We're going to say that they're each going to be 1 unit in length. Now, what we want is to figure out what's the hypotenuse. Well, since a squared plus b squared is equal to c squared, and 1 squared plus 1 squared is c squared will equal 2, so c will equal the square root of 2. That's the length of the hypotenuse. Now that we have our three sides, we can determine the sine, cosine, and tangent values in exact figures. Now, the sine of 45 degrees is going to equal opposite side. Well, the opposite side to 45 degrees is 1 over the hypotenuse is root 2. So the sine of 45 degrees is going to be exactly 1 over root 2. That's simple. Now the cosine of our angle of 45 degrees is going to be adjacent over hypotenuse. The adjacent side is a side length of 1. The hypotenuse is also root 2. So again, it's going to be 1 over root 2. Lastly, what's the tangent of a 45 degree angle? Well, the tangent of a 45 degree angle is going to be the opposite side compared to the adjacent side, which is 1 to 1, or just 1. There you have the sine, cosine, and tangent values in exact figures of 45 degree angles. Let's continue with an equilateral triangle with side lengths of 2. Now when you notice this, you have an equilateral triangle. All the angles are 60 degrees, and all the side lengths are 2 units long. But what we're going to do is cut this in half and throw half of this triangle away. That's going to create a 60, 30, 90 degree triangle, which is what we want to work with. We're going to cut half of it away. We're going to erase that. The top angle is going to be half of 60, which is 30, and the bottom angle is going to be 90 degrees because we cut half of that away. Now what we need to do is figure out what that side is that's missing. We know side A is 1, B we don't know, and C is 2. So we're going to say a squared plus 1 squared equals 2 squared, which means a squared plus 1 is equal to 4. A squared is going to equal 3. If we subtract 1 from both sides, take the square root of both sides, and a is going to be root 3. Now that we know that side is exactly root 3 in length, now we're going to figure out our sine, cosine, and tangent values for the 30 degree angle and the 60 degree angle. So if we started with 30 degrees, the sine of a 30 degree angle is going to be the opposite side, which is 1, over the hypotenuse, which is 2. So that would be 1 over 2. Next is the cosine of 30 degrees, and that is going to be, well, the adjacent side is root 3 to the 30 degree angle, and the hypotenuse is 2, so that would be root 3 over 2. And now we have to figure out the tangent of a 30 degree angle. Well, the tangent of 30 degrees, well, from 30 degrees, it's opposite over adjacent, which is 1 over root 3. Lastly, we have to figure out the 60 degree angles. So now we're going to look at this triangle from the bottom. The sine of 60 degrees is going to equal the opposite side, which is root 3, over the hypotenuse, which is 2. So that's root 3 over 2 exactly. The cosine of 60 degrees is going to be adjacent over hypotenuse, which is 1 over 2. And the tangent of 60 degrees is opposite over adjacent, which will be root 3 over 1. And that is our final answer. So there you have how to derive the exact values, the exact trig values for 30, 60, and 90 degrees, 30, 60, and 45 degrees, pardon me, and what those values are. You will need to be able to reproduce those on an assignment and on a test. You will not be given this. Your assignment then is to complete page 83, numbers 1 to 8.